Okay, hello everybody. Let's start with the lesson today. Well, my name is Juanvi Martínez. I introduced myself already in the previous two lessons, but again, just in case. Juanvi Martínez, I am a software engineer at SAP Concur for the last 2 years and a half, something like this. And today I'm gonna be your teacher. I have to warn you that today we have a quite interesting class. So there's a lot of information. Basic information that I will try to explain as the easiest way possible so you can all understand, get the concepts, and then apply them in our future lessons. So basically today, what we are going to talk about is about how we are handling this way. Classes in Kotlin, different types of classes that we can use in Kotlin, what are the interfaces, how we can use them or apply them to our classes, and we will see also the abstract classes. I will explain also the differences between interfaces and abstract classes in Kotlin. I'm gonna share with you in Slack the document that we are gonna be using today, just to keep the contents of the lesson. And I will share also my screen. Okay. Here we are. Okay. Can you all see my screen? I hope so.
Yes.
Perfect. Okay, so as I said, here is the document that I shared with you on Slack. What we're going to see is first, classes in Kotlin, how we can define normal classes, how we can define data classes, what's the difference between them, when we will use one or the other, abstract classes or interfaces, maybe in different order, first interfaces and then abstract classes. Here you have some links that you can use wherever you want, just to our Slack channel, to our GitHub repository, but it's a little bit redundant because you're already here, and a link to the Kotlin manual, especially to the lesson that we are gonna learn today about classes and inheritance and all these things. Okay, so basically, I'm gonna start with a little bit of theory because I know from the first lesson that there's a lot of people that have very basic knowledge of programming, or maybe no knowledge of programming. So I'm gonna start explaining just very briefly what is the object-oriented programming, what are classes, why we need them, what are objects, and all these things. This is like a basic concept that we will use during all this Kotlin Academy. Okay, so basically, today we are going to learn are classes, abstract classes, and interfaces. Classes, why classes? Well, because they are an important concept on the object-oriented programming paradigm, okay? So this object-oriented programming allows us to solve complex problems by using objects. I mean, we have a big problem and we split it in objects just to divide the complex problem in small small problems, so we can solve them easily. I left here also a link to the Wikipedia where everything is explained, because there's a lot of theory about this. The main concept that you have to get about this is that we are using object-oriented programming because we want to model our problem into classes or objects, so then we can treat them separately and achieve the result easily. So in this case, what are classes? What's a class? Basically, as I'm saying here, class is a blueprint or a set of instructions to build a specific type of object. Think on a real world example, a car. How we would define a car. So basically, our car will be our class, and this class will have to specify what can do and what properties has. Parts of the class, basically, click here. Yeah. we have the name that it identifies this, this class. In this case, we have the car. Then we have the constructor of the car, of the class. That is a special kind of function that is used to initialize this class. We'll say later how. Then we have the methods of the class. There are what can this class do? For example, if it's a car, we have the methods like we can drive, we can set the speed, we can get fuel, refuel. So what's the functionality that this class can perform? And then we have the attributes of the car. Attributes or properties are basically just variables inside of this class that will store information, will keep the state of our class. Of course, each of these, each class or an inside of each class, each method and attributes have miscibility modifiers. What are miscibility modifiers? Well, there are modifiers that we are using when declaring, for example, a function to say, hey, this function is only visible inside of this class. It means that this function is only usable by the class car. We can also say that, for example, okay, this function is public. It can be used from wherever. Okay, so we are, for example, in one class that is using another class. From the first class, we can call the other function. We will see all of this in action in the task that we are going to do very soon. So now we know what is a class. Basically, the definition of the object that we want to model. Here in this example, we have the car. We can also model a person. What would be the methods of a person? Breathe, walk, run, something like this. What could be the attributes of this person? Name, surname, date of birth. Just a few examples. Okay, so once we define our class, how do we use it? How do we put it into practice in our code? Here is what we are using, why we call objects. An object is basically an instance of this class that we have already defined. Basically, an object is nothing but a self-contained component which consists of methods and properties to make a particular type of data useful. In our example, we have defined the class car. The objects will be the Polo, a Mini, a Beetle, specific objects from this class. In the other example that we have shown, the example of a person class, the objects will be, in my case, me, Juanvi, or Vladimir, or Johanna, whatever. So we are objects, but don't treat us like that. Okay, that's a really weird joke. So what's the difference between a class and an object? As I said, the class is just the basic structure, the blueprint or the prototype that defines what this class can do. Okay, and the object is a specimen of that class. Is it clear? I hope so. Okay, so once we have defined these two terms, class and object, let's put them into practice. So I want to ask you to open our friend IntelliJ IDEA. Where is it? Here. Create a new project. Let me share like this. Okay. Create new project. We'll choose, in this case, Gradle, Kotlin, JVM, and check in Java. Okay, we are doing it a little bit different from the other weeks, because on other weeks we were choosing Kotlin, JVM IDEA. This time is Gradle, Kotlin, JVM. Okay, once we have selected, let's put the name lesson03, for example. Here you can do, you can put the name that you want. Doesn't matter, it's just to create the project. We have the project created. We can close this first file that we have opened by default by the IDE. And as I say here in the steps, let's create a new Kotlin file in the source folder with name main, as we were doing before. So Kotlin, new Kotlin file, let's call it main. And we are adding this code, just copy paste if you have the document open. Once we have it, we can just run it to check that everything is okay. We should see in the console just hello world. We have been doing this in the last 2 weeks, so it shouldn't be a problem, I hope. So do we have it? If yes, please give me a hands up or a yes or whatever. Okay, let's continue. So we have finished with the project creation. Everything is working. Here we can see our hello world. Very useful. So now let's go into the interesting part. Let's work with classes. The first task that I'm going to ask you to do, but I will do it with you because this is your first time that you are working. For most of you, first time that you are working with classes, so you don't know exactly how to do it. So I will do it with you. First task will be to convert the previous Hello World implementation into an object-oriented version. Okay, so we have this code. We have to make it object-oriented. As I explained before, to make it object-oriented, we have to think in objects to solve the problem. How we can do this? Using objects. Basically, I can do it like this. Let's define a class that we know what it is. The class will be greeter, for example. And this class will have just a function called greet that will just do this. Okay, easy peasy. This identifier or this keyword specifies or defines a class. Then we need to set the name of our class. And inside of the curly brackets, we write our functions or our properties. For example, we can say like this, as you know. We can write here whatever we want and as many functions, as many properties that we need. Okay, we have defined our class. How do we use it? Because we know that we need the class, but then the object of this class in order to make it work. Inside of the function main that this is the entry point for our code, we need this function yes or yes, because otherwise it won't work. Here we define a variable called greeter, and it will be of type greeter. Okay, we are defining this variable, but we need to initialize this variable. Doing this, we have created this variable greeter, and it's already ready to be used. If we do something like this, we are just defining the variable greeter, but it doesn't have any functionality. It doesn't work. So we need to call this function that is the constructor of the class. As I mentioned here in the document at the very beginning, what are the parts of a class? The name, greeter, constructor, that is the function that we invoke in order to make live our object, attributes and methods. Here we have only methods, no attributes. So basically we are using this variable like this. We create the variable, we specify the type, and we call the constructor. What is the constructor of a class in Kotlin? Well, here, if we don't, for people who are coming from Java, this will be a little bit different. The way we specify the constructor in Kotlin, it's a little bit different. If we don't say anything, it means that we are using a default constructor. If we want to use a constructor by passing some variables or whatever, we can do it, for example, like this, specifying the constructor in the same line when we are defining the class. And here we are passing, for example, the name. As you see here, right now, it's complaining because we haven't passed the variable used to initialize this object. Here we could say name Juanvi, and it will work. The funny thing of Kotlin is that if we are not going to set, for example, this constructor private, we can omit the whole word and leave it like this. So I'm not going to go deep into the constructor thingy because it's a little bit difficult thing. But just to let you know, we define the class. We can pass here the constructor parameters that we want. If we do it like this, this variable will be only visible for the initialization of the class. So if we want to use it here, it won't find it. If we want to use this variable all along the class, we have to specify it like a val. You see that here it changed. We are calling here the constructor just to make this variable usable. And once we have it, we can just call greeter.greet, and that's it. Here you see that the type of this variable is like a little bit grayish because it's not really necessary because we are specifying here the constructor of this class. So the Kotlin compiler, it's clever enough to know that the type of this variable. So we can leave it like this. If we run it, here we set hello world Juanvi. We can pass here whatever we want. It will always take it and print it. Okay. Also, here in the document, we're talking about the visibility of the modifiers, the visibility modifiers in Kotlin for the methods and attributes that we are using. As I specify here, the default visibility modifier, if there's nothing written, is public. So as you can see, this function that we just created doesn't have any visibility modifiers at the beginning of the definition. So it means that it's public, and that's why we can call it from here. If we set it private, here is complaining, and the error message cannot access grid because it's a private gritter. So if it's private and we cannot use it from here, what's the purpose? Well, basically, because we could create here another function called grid1, for example. And inside of this function, we can call this other function. Here I'm explaining each visibility modifier, what's their range of usage. So for example, this private, if we use private, it's only visible inside the class only. So this private function is only visible inside of this scope. Then we have protected. That is like a little bit, it's not so restrictive as the private modifier. And as I see here, with protected, it will be visible to the class and its subclass. So for example, if we have this class and then another class that is extending this other class, the visibility of this method will be in these two levels. Then we have the internal modifier, which means that it will be visible inside the module only, okay? So here we are only using one module, so it doesn't matter if we set into internal, because it will be only always visible. But if we have an application multi-module, then this will be a quite interesting modifier to use, just to restrict the usage of this function to the module. And finally, we have the public, that, as I said, is the default modifier, so it's not necessary to specify it. We can leave it like this. This is working again, and we can get rid of this method because it's not used. Okay, is it clear? Any questions? Okay, so let's continue. 6:20 already. So the next one, next exercise, task 2. We are going to define the class car according to the image above. Okay, so we have this class, and we are going to define it in Kotlin. Okay, so let's do it. I'm going to delete this gritter because we don't need it, and I want to make it clear. So let's go to the class car. Class car. What do we need for this class car? I said something here. Okay. We need two attributes, fuel and max speed. Well, fuel, it will be an integer. Max speed, for example. Methods, refuel, get fuel, speed, get speed, and drive. Let's add them. Fun, fuel. Drive. Okay, I have added 1, 2, 3, 4, 5 methods. 1, 2, 3, 4, 5. Plus, in the instructions of this task, I say, add also two new properties, name and max fuel. So, two new properties. Name, that will be a string. And whatever. Something else. Name, max fuel, and max speed are constructor parameters. Like this, we have defined the properties inside of the class, but they are not constructor parameters. What does it mean? That when we are going to use this class, we would need to set each of these properties by itself. So if we want to use this car, for example, var car1 will be a car. And actually we can't because of this. We'll have to do car1 dot max fuel. Okay, what? 60. Car1 dot what fuel that it has right now? 0. So we'll have to do this for each property that we want to set by default. If we set these parameters as constructor parameters, name, max fuel, and max speed, okay. What do we achieve with this? Well, you see here that already when we are trying to instantiate this, this object, is complaining because we haven't passed any value for these parameters. So, for example, name, it will be like people. Then it was max fuel 50 and max speed 150. By doing this, we have created a new object, car1, with these values. So if we want to do like this, okay. So now if we say car1, you see all the properties that we have here that we can use for whatever, max fuel, fuel name, max speed, plus the functions, drive, get fuel, get speed, refuel, set speed. We can call all these functions and properties from this main function to do whatever we want, okay? How we can restrict this? Well, miscibility modifiers, for example. We don't want that the max fuel will be accessible from the outside of this class. Let's mark it as private. Max speed, the same. Name, maybe it doesn't make sense. And fuel, also. All of these are private. If we come here, we check again, drive, get fuel, get speed, refuel, and set speed. There's no way we can access the properties. Okay, next step. So drive function will go from 0 to max speed, and then when reached, it will call the stop function. How do we solve this? Well, I guess, and I hope you remember last week's lesson about the for loops and all these things, because we are going to implement it like this very easily. So we said that we need also one found stop. Drive will go from 0 to max speed, and when reached, it will call the stop function. Drive for speed in 0 to max speed. What can we do? For example, we can do this. Okay, easy code. Go from 0 to max speed, and when it's max speed, call stop. for speed in 0 until max speed, we are setting the speed just to do something. And once this loop and this for loop finishes, we call stop. Then stop will go from max speed to 0, and when reached, it will print a message. So let's do the same. For speed in max speed down to 0. This is the difference when we are doing a for loop in increasing order, and when we are decreasing the value. We have to set, instead of this 2 dots, we have to use the this down to thingy. Let's set also the speed here. And when finished, speed in the set speed method. Yeah, probably yes. Yeah, thank you, Raul. Current speed equals speed. Yeah. Let me put this down. Okay. We can print here a message like finished, for example. Okay, we have function drive goes up to max speed and then goes down. It's creating like a triangle of speed. And then the stop from max to down and prints this message. That's it. Okay, so now we have in the main function, create 2 instances of the class car and let them race against each other. Let's race. So I'm gonna add one more thing, because here we have the drive, but if we have fuel 0, it's not possible to drive. So if fuel equals 0, we can just return or say I need to drink, for example. So car 1, what method do we have here? Maybe set speed. We can set it as private because we don't need to make it public. We don't want somebody just to set the speed of our car for now. Let's drive. We have 1. For example, we have car 2. It will be a car name Golf. Fuel 100. Max speed. Let's make it similar so it's not confusing. 250. Okay, we have created 2 instances of our car class. One is car 1 and the other is car 2. And we just want to drive. Okay, what do you think it will happen? I'm gonna go a little bit fast. So when we run it, first it will complain because we didn't set any, they don't have any petrol. So first thing that we have to do, for example, car 1 dot refuel, and the refuel we are passing like fuel integer fuel. Okay, here I just created, or I'm returning this variable in this function. Get fuel returns fuel. Why? Because fuel is private. So if we want to use get fuel outside of this class, we are able to do it. But if we want to access directly this, this property from outside of this class, we are not able. So we are using this accessor. Okay, so let's refuel car 1 with 50 liters, car 2 refuel with 25. Let them run. Okay, we need to do something a little bit, something like this, just to know which car is finishing. Okay, here we have first finish the Beetle and second the Golf. Why is that? Sorry. Why is that? Basically, because this main function is running line after line. So first we create this instance. Then we create this second instance. We refuel car 1, we refuel car 2. Then car 1 starts, it goes up, it goes down, and once it finishes, car 2 starts. So here, of course, if we change the order, now car 2 will finish earlier. You see? This problem, we will solve it, not in this lesson, because I think we are running out of time and I want to go fast. But in lesson 7, if I'm not mistaken, when we will take a look at the coroutines and multi-threading and parallel execution of methods, or whatever you want to call it, we will see how this works. Okay, we have our 2 cars here. What's the problem of this implementation? Well, the problem of this implementation is, for example, we are considering that both cars are driving the same way. But in real life, probably this is not true. For example, one car will accelerate in one way, having in mind some variables or whatever, or some power of horsepowers or whatever. Another car will do it differently. So we have to make this a little bit better and model our class in a different way. And here, oh shit, I forgot about the data classes. Okay, I'm gonna go fast with the data classes. And then I will explain how we can improve this definition. So in Kotlin, we have classes that we have just learned, and data classes. Data classes basically are used to store fields of information, okay? Just for holding data. The main difference with a data class, with a normal class, is that when we define a data class, is because we want to let the compiler know that we are just holding data. So the compiler in Kotlin is clever enough to create this bunch of functions for us for this data class. Otherwise, in a normal class, we will have to specify this toString equals hashcode, copy, and component. So the task here in this section is define the data class car data. We're going to do it very fast. So we have here the class car. To define a data class car data. The main difference with a normal class is that data classes needs the properties in the constructor. So we'll need to define these guys here, and we are done. Okay, we can set them as public. Okay, if we remove this part, you don't see a big difference between these 2 definitions of class. One is a data class and the other is a car. But if we right now do bar car3 equals car data, if I'm not mistaken, yeah. And we copy this in here, and then we do println car1 and car3. I'm going to do this. Okay. We have created our variables, our objects. One is instance of car and the other is instance of car data. And we want to print what's inside of these two variables. When we print them, we see that the first one, car2 or car1, yeah, it's coming in this format. And the second one, the data class, is coming in this way. Why? As I said here, the compiler is creating, in this case, the toString function for us. If we want to have the same result in both, in our class, we will have to specify our toString, overriding this function and just trying to achieve the same fancy result. Okay. Data classes are quite useful, especially when we are dealing with data coming from network or from databases, something like that. They are quite useful because one of the functions that they have also implemented is the copy. For example, if we have this car and we want to create a new one, car4, with just changing the max speed, for example, of this one, we can do car3.copy max speed equals 200. And that's it. We have created a new instance of car data with the same values of this instance, but just changing the max speed to this one. If we do like this and we print 4, we see that these two instances have the same information except the max speed that we just changed. So this is a very convenient way of just changing one field in an object, just by doing this, just by selecting the instance of the object that we want to copy, and specifying the property that we want to change. That's it. Okay, let's continue fast and furious. Remove this. Any questions? No? Okay. So before I was saying that we have defined this, the class, the car data, the car class, and it's not very convenient because it only specifies the behavior for one type of car. So we cannot, if we create multiple instances of this car, of this class, they will have the same behavior, or the same implementation. So how we can abstract a little bit more the behavior of this model? Basically, by using interfaces. An interface defines the set of methods or functions that are applicable to something that we want to model. For example, we want just to model the whole car object. That it will be a compound of every definition of car, every model, every whatever. The interface will be the contract that this object will have to satisfy to say, hey, this is a car. How do we achieve this? Well, basically, to create this contract or this interface, we start with interface, car. Let me change here because here rename class to sports car. Okay. Let's rename this to sports car. And let's create the interface car. And inside of this interface, we think, okay, what can a car do? A car can drive. A car can stop. What else do we have? A car can refuel. a car can get fuel, for example, this for functions. As you see, I'm just creating like the prototype, the signature of the function, just defining what the car can do, but I'm not going into the implementation because I'm just saying, yes, this is a car. It can do this, 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 but how it does this car, I don't care. This is just the contract. You have to satisfy this contract to say that you are a car. How do we apply this to our sports car or to any other class that we can create? Well, for example, let's create class my car. And here at the end, we add this guy and car. With this, we are saying that this class have to implement the interface. It must be a car. And as you see, the compiler is like, or the IDE is notifying us that something is wrong. If we leave the cursor here, my class, my car doesn't implement the members. How do we implement? We press Alt Intro. I think it's in Windows, or Option Intro in Mac. We have this fancy menu, and we just click on Implement Members. We get this. We select all of them. Okay. And as you see, automatically we have here the functions that we have to implement by ourselves. Bernardo, intro is enter or the return key. As you see, we have this thing here already for us. What happens if we already implemented our functions here and we don't want to copy them to a new class? Easy. As you see, by default, all the functions that we have to implement have this override modifier at the beginning of the function. So we can just go to our sports car, say that it's a car, it's complaining, and as you can see here, get fuel, we are overriding. Get fuel is an end. What else? Drive. Let's override it. What else? Stop. Override it, and I think that's it. And refuel. That we need new fuel integer. It will complain this. Override. And here we are. What's the advantage of this? Well, we have created like a sports car. Sports car have this drive, stop, refuel, and get fuel. What if we want to create another car, city car, for example? We do the same. We implement the members. And for example, a city car will drive a little bit slower or not so fast as the sports car. It will have also like a slower reaction, stopping, whatever. So it's easy to specify the behavior of each type of cars at this point. Okay. So this is about interfaces. And finally, I have to talk about abstract classes, but we are running out of time. So how is everybody? Are you still with enough energy to finish with this? Okay, I see. Yeah. Okay. Let's do it. Yes. Okay. So now the next and last point, because here I have something that we are talking about. I talked before about the coroutines that we are not gonna do. At the end of the class, if you feel that you want to do it or you want to try, Just you can do it at home. It's quite easy to implement. I have specified here all the steps. So now let's talk about abstract classes. Okay, we've seen class, object, interface, and now the abstract class. Last concept of our lesson. Abstract classes are classes that contain one or more abstract methods. Abstract methods are methods that are not implemented, similar to the interfaces. Actually, I'm writing it here. It's a method that is declared but contains no implementation. Abstract classes may not be instantiated. You cannot create objects of an abstract class and require subclasses to provide implementations for the abstract methods. It's a similar concept to the interfaces, okay? But what are the differences between interface and abstract classes? An interface can have functions with default bodies. Okay, I didn't say this before, but in our interface, for example, the refuel function, I think it's clear that every car has the same way of refuel except the electric ones. But for example, there are the ones that are with benzene or diesel or whatever, they are refueled the same way. So we can specify just like the default body, like print then refueled, something like this. We can okay, we can specify that the basic or the common implementation to all the classes that will stand our will implement our interface. So in that case, here we won't need this because it's common. It's already implemented in here. I have something. Yeah. Okay. 4 minutes left. Okay, let's do it in 4 minutes. To Bernardo, interfaces like class inheritance. No, the interface is like the contract that you want to satisfy in a class. Class inheritance, for example, if you have one car and then or one vehicle and then another vehicle behind that is inheriting some behavior or properties in the upper layer. Okay. So as I said, what's the difference? Interfaces can have default bodies, but interfaces cannot hold the state. Okay. In an interface, we cannot say, I want to define a variable named name. It will be a string, and it will be golf. No, this is not allowed. Interfaces cannot hold state. Property initializers are not allowed on interfaces. Okay, nothing. We cannot store the state. Interface is just to satisfy the functionality that must meet the class. That's it. But abstract classes can have everything the interfaces have, but also they can have fields, constructors, allowing to hold state properly. And then functions and properties with default bodies in abstract classes can be final, and they are final by default. If you want to take a look at this, I recommend to read the Kotlin documentation because it's a very interesting topic. So how do we define an abstract class? Easy, abstract class. And here will be like, I set it here, called abstract in the task. How does this work? Well, for example, we want to define also function drive. Okay, we have two functions, drive and drive abstract. Drive, as you see, is not complaining because we can implement it. We can say, okay, just drive. But what if we want to create, like, to have like a definition or the implementation that it will be responsibility of this class. So we mark it as abstract, like this. You see, for now, we don't see any big difference with the interface, but here we can say name, string, golf, and it's not complaining. Abstract classes can hold state, and this is very useful for in some cases. What's the analogy here? In our sample, we have the interface, that are the expectations from any car, any type of car. Then the abstract class, that would be, for example, the group of this car. And then we have the sports car, or the class, that is the specific model of car. So you see, we have the contract, this is a car, this is a car in this group, and this is this model in this group. How do we put all of this together? Well, basically, the abstract class can implement our interface car, and our sports car can implement the abstract car, the abstract class. As you see, here is complaining because we have it already defined in the abstract class. This would be, is complaining about constructor invocation, okay, like this, and we have to implement this guy. This would be how we will link all our setup: interface, contract, abstract class, something more specific, sports car, even more specific. Okay, and basically that's it from me. I know it's a lot of information. So if you have any questions, please ask me. And I would suggest also to go through this document again. Try to read it completely, understand. Try to do again the task by yourself. If you want, I can post the code of this all these tasks somewhere so you can check it and compare with yours. Okay, so I will add this code to our GitHub repo. And yes, and as Vladimir says, ask questions in our Slack channel. We are there always, so yeah, we can solve any question that you have. Okay, so that's everything from me. I hope you enjoyed. I hope you don't have like a big head of all this information.
Thanks a lot.
You're welcome.